Hello and welcome to episode 1 of many in a series of videos where I'll be taking you through building a custom system for Foundry VTT. I've put timestamps in the description, so you should be able to skip ahead if you want to, but first some context. There are already some good tutorials on the Foundry VTT community wiki, notably the system development from start to finish written by Asacolypse, which has been the basis of my research. This video series is not a replacement for these, and if all you want is to quickly create a new character sheet or hit the ground running with system development, you should go read those instead. I've put links in the description. Here, we are going to write the system from scratch. The wiki tutorials rely on boilerplate systems, which are great at getting you going quickly, but it's less good for people who want to have a deeper understanding of the API. Also, if you ever want to deviate from the boilerplate, it can be tricky to figure out what to undo, especially if you don't know how it works. Before we begin, let's manage expectations. First, I'm assuming you know what Foundry is and the basics of how it works as a user. Second, I'm assuming that you'll know the basics of HTML, CSS, and JavaScript, as this is what we'll be writing our system in. To put things in context, I write C# code on a daily basis. That said, prior to Foundry, I had not touched HTML, CSS, or JavaScript in over 16 years, so I was definitely rusty getting into this. I'm going to assume that you start from a similar place, so I will be glossing over the absolute basics. Third, I'm neither a software engineer or a web designer, which means that the way I write things might not be the cleanest or most performant way of doing things. Fourth, I'm not an expert in the Foundry VTT API, so there will inevitably be things that I won't be able to explain properly because I don't understand all of it. And finally, since I'm going to show the system I've built, I can only talk about what I had to develop. And by the end of this series, I can't guarantee that I'll have touched everything there is to know about system building. I also wanted to give a shout out to the system development channel on the Foundry's Discord server, which has been pretty helpful when I got stuck, and I highly recommend you hang out there as you work on your system. A quick word on my development setup. I'll be working in Visual Studio Code, doing source control with Git hosting the project on GitLab. I highly recommend doing source control, even if it's just you working on it, because it will provide a backup solution as well as a way to backtrack when you inevitably break things by tinkering too much. Though setting this up is outside of the scope of this video, as it is not strictly necessary. So what are we making? I'm going to take you through the steps I took to build a system for Feng Shui 2, created by Robin Laws and published by Atlas Games, who has kindly given me permission to release the system publicly when it's done. I picked this one because it's a game I want to GM online, and it has relatively few moving parts compared to, for instance, D&D, which should make it easier to build and explain. Okay, this was a long intro. Let's actually get started. First, we need to pick a place for our work. The simplest way is to work wherever Foundry stores systems. I wouldn't recommend doing this once your system is published, but while you're in early dev, it will make iteration a lot quicker. You can find out where Foundry stores its data by going into the app's configuration and looking for the user data path field. I moved my data folder away from the default location to a place that's more convenient for me to manage. In there is a systems folder where we can create a folder for our own system. I'm going to call this one FS2E for Feng Shui 2nd edition. At the heart of every system, there are two files. The first one is system.json, so we're going to create it at the root of our system folder. System.json is the manifest that tells Foundry where to download the system once it's published, and which files to load, as well as other metadata. Let's take a look at the most common fields. First, our system needs a name. This name must be the same as the name of the folder in which the system files live, so in our case it's going to be FS2E. Then we have the title field, which gives the system a more user-friendly name to be displayed in the Foundry system list. There's also a description field that can go with that. Let's go with a simple a system for playing Feng Shui 2 games. You can put whatever you want in there. We can also specify an offer for the system, which in this case it's going to be me. Next, we need to specify a version. This is used to tell users whether they need to update, and you can use that information to see if the user's world need to be altered to be compatible with the new version, also known as migrated. There is no prescribed format here, nor there is a rule for when to upgrade the version number. The only recommendation here is to go with something that's easy to compare in code. As long as your system isn't published, it doesn't matter a great deal. I personally go with a simple decimal number, which I increment by 0.01 whenever I make changes to the model, which we'll get to in a moment. By the way, if you've never seen JSON files before, just know that the order of the fields is not important and you can rearrange them as you see fit. Next, we need to specify which version of Foundry our system is compatible with, and we do this through two fields. Minimum core version, as the name suggests, it's the oldest version of Foundry that this system will work with. To keep things simple here, put the version of Foundry you're using when you're starting to build the system. You only need to change that number if you upgrade Foundry and rely on new features. The second field is compatible core version, and that is the most recent version of Foundry in which you know your system works without any issues. This should be updated whenever you update Foundry after you've checked that everything still works. And for the last bits of admin, there are three fields called manifest, URL, and download, which we're not going to cover right now because these don't need to be set until the system is ready for publication. Okay, now we're starting to actually define our system. First, we have to say where our code lives. You can write Foundry code in two ways. Either the traditional way by passing a list of JavaScript files to load, or by using ECMA script 6 or ES6 modules. I'm going to use ES6 because it's more similar to the way I'm used to working, and as opposed to the alternative, it doesn't require me to maintain a comprehensive list of files in the system.json. So in the ES modules array, I'm just going to point to the JavaScript file, which will be the entry point to my system's code. I haven't created the file yet, but we'll get to it in a moment. I'm going to put it at the root and call it fs2e.js. At this point, it's worth noting that with the exception of system.json and template.json, you can name and organize the files however you want. I'm following a similar structure to the system developed by Foundry's creator, because most of the time I don't have a good reason to deviate from that. Whenever I refer to conventions, what I mean is the way it's done in Foundry's core systems. Right, after we've declared our code file, we need to do the same with our CSS style sheets in the styles field. Likewise, I'm going to go with fs2e.css at the root of the system. That's all we need to do right now. There are other fields that are important to know, so I'm going to very quickly go over them, but I'll get back into it in more details as and when needed. First, we've got packs, which is a list of compendia that you want to bundle with the system. Languages is where Foundry is going to find language packs if you develop your system with localization in mind. You can specify the default scale of scenes with grid distance and grid units so that Foundry can convert number of grid cells into distances or vice versa. For combat, you can use primary and secondary token attributes to specify what actor attributes to display on the token. And finally, you have initiative. Foundry tries very hard to make no assumption about how your system might work, which is the reason why some things that you might think are basic are not part of the core system. One assumption it does make, however, is that all games have some concept of initiative to determine turn order in combat. In the system.json, you can define the role formula used for initiative, but you can also change that in code. The second critical part of the system is template.json, which defines the base model of your system, i.e. what types of actors and items you can create, and what attributes they have. Right now, we're just going to add an empty dictionary for actors and one for items. These, by the way, are collectively known as entities. We'll need to fill those in, but before we do, let's check that our system is actually ready to go. If I open Foundry and go to the Game Systems tab, I should see my new system show up, and I should be able to create a new world using it. So now I can go to the Game Worlds and create a new world using this system. Let's call it Tutorial World. Okay, this loads. This is a good sign. Though, if I try to create an actor or an item, I'm not given the choice of what type to create, and that's because I haven't defined any types yet. So let's go back to the template.json and do that. This is where you need to start doing a bit of planning to make your life easier. You don't have to get the template right the first time because you can add to it whenever you need to, and you can make changes after the fact. But changing the template for existing types likely means you'll have to rewrite some code, possibly recreate some entities and/or write migration scripts. So the less often the template changes, the better. I like to start by defining items because they tend to be simpler than actors, and for the sake of brevity, I will only show a few examples. Let's start with weapons. All entities have a name and an image by default, so we don't need to create fields for that. In this game, weapons have three main stats: damage, concealment, and reload. So I'm going to create a field for each and set their default value to 0. But weapons have other properties that we need to track. Some weapons have an attack bonus against certain types of NPCs, mooks. So I'm going to add a mook bonus property. Also, shotgun have a special marker whereby you can get an extra point of damage if the player mimes sliding the pump action while making the appropriate noise. So we can add a pump action property that we can set to false as default. And finally, in Feng Shui, characters can have several attack stats, and weapons need to be used with a specific stat. So we need to track this too. I will add a attack with stat and give it the guns value by default, as this is the most common type of weapon. We'll define what guns means later. The key point here is that you may need to look beyond stats to figure out what properties you need, and sometimes you might need to keep track of things the rules aren't even explicitly mentioning. It mainly depends on how much automation you want your system to do. It's also worth noting that while some of the stats only apply to certain guns, there's no real reason to make one type of item per type of weapon, because there is so little difference. We can always ignore the fields and only display what's relevant. Plus, it gives GMs the flexibility of making weird custom weapons. Let's make another item type, vehicles. The rules tells us that they have 6 stats: acceleration, handling, squeal, frame, crunch, and whether they're a personal vehicle. But on closer inspection, squeal always equals handling plus 2, and crunch always equals frame plus 2. Because this can be calculated, there is no need to add it to the template. It can be done in code. A rule of thumb is that every attribute that can be derived from another doesn't need to be in the template, while everything a player has to enter manually should be. As you may have seen looking at other systems, certain character-specific elements such as class, skills, or feats might be easier to manage as items rather than actor properties, and therefore don't need to be in the character's template. Speaking of templates, as you create item and actors, you might find that some of them share properties. Weapons and vehicles, for instance, could do with a description field. But rather than copy-pasting the field into each item's definition, we can create partial templates that various types can refer to. I can define these by adding a templates field under item and then add one dictionary per template. Let's call this one item description and add a field called description. Then, in each item type, I can point to a list of templates that this type should use on top of the things that are unique to it. Now, if I get back to Foundry, I can shut down the world, go back to setup and reopen the world. This will reload the model, so now if I go to create a new item, I can now select between the 2 types I've created. We can now make a weapon and edit it, or we could if we had an item sheet for it. Item sheets are what Foundry calls applications, which are modular user interface elements. Essentially, everything that opens as a floating window is an application. To build our own item sheet, we'll need to extend the default item sheet class. By convention, the various classes go in a module folder, though as I said earlier, you can organize files however you want. So I'll add a module folder, then a sheets folder, and create a file called fs2itemsheet.js. In there, we can define our class, which we're going to call fs2itemsheet, making it extend ItemSheet. The export keyword is so that we can import this in another file, and Foundry needs the default in order to find the class. There are a couple methods we'll want to override, but let's do one thing at a time. First, we need to specify which HTML template the sheet should load. This is done through the getTemplate method. All we need to do here is return the path to an HTML file. The path will start with systems/the name of your system, and by convention, HTML templates go in a templates folder. Also, while each type of item is going to have its own HTML template, I'll be using the same item sheet class for all. You don't have to, but splitting them out isn't really worth it here. This means I have to do some string interpolation to get the correct template based on the type of item this sheet has to display. Next, we need to create this template. As a starting point, we're going to copy the default item sheet. What I like to do is add the core Foundry folder to my VS Code workspace so I can refer to it as needed. This lives wherever you installed Foundry, then resources, then app. Now I can copy the item sheet template and paste it in my system. I'll do the sheet for weapons, so we'll call this weapon-sheet.html. I'll just make a slight modification to the template just to see if it's loading properly. Now we have to tell Foundry that this new sheet is available to use. It's finally time to create our main JavaScript file, fs2e.js. We'll start by importing the class we've just created. Foundry gives us a number of hooks to latch onto, which allows our system to react to what's happening when users interact with the interface. For now, the one we care about is the initialization hook. We're doing this by calling hooks.once with the init parameter, and then we can define an anonymous function right there doing all the system initialization code that we need, which right now isn't much. Just like in the DND5e system, we're going to log some message here just to make sure our system code is loading properly. Then we can register the new sheet and make it the default sheet for items. While we're here, we can also unregister the default sheet so that it's not an options user can switch to. Now, if I go back to Foundry and reload the world using the F5 key, I can go to the Items tab, click on my cool weapon, and yay, our custom sheet is loaded. We can double check that by clicking on the Sheet button at the top of the window and see which class is being used. This is all good, but we're still not any closer to being able to edit this item. The last thing we'll look at today is modify the HTML template so that we can edit those weapon properties. For most of its HTML content, Foundry relies on Handlebars, a simple templating language. You can recognize this by all the double curly brackets peppered in the HTML. Given a template and a JavaScript object, Handlebars will generate HTML content that Foundry will then render to the screen. This JavaScript object is called the context. This is where we need to talk about entities. The entity class, which items and actors are children of, has a property called data. This is an object that contains all the interesting info about the entity, like its name, type, and image. Where things might get slightly confusing is that entity.data itself contains an object called data, and this is where all the properties we've defined in the template.json reside, which does mean that most of the info you'll care about lives in a place called entity.data.data. It's a bit weird, but you'll get used to it. The context that gets passed to Handlebars for entity sheets is a modified version of entity.data. Actually, we'll need to make our own modification for the weapon sheet, so let's learn how to do this now. If you remember the weapon model from template.json, we have a field defining what stat the weapon needs to be used with. Because there is a fixed list of valid values, rather than let the users guess, we can provide them with the list. The DND5e system does this by creating a configuration object named after the system, stored in a config.js file. So we'll do the same. Then we can add variables that we'll make accessible from anywhere else in the code. Let's add a dictionary where each key is a possible attack type and value is a prettier name to display in the interface. However, if I just type those names in, they are essentially hard-coded, which is fine if you're writing the system for yourself, but if you ever intend to make your system available to the public, you need to have localization in mind. In which case, it's better to deal with it now than try to retrofit it when your system is complete. So we have to create a language pack. This should hopefully be our last detour. A language pack is nothing more than a JSON file containing a huge dictionary of strings for all the bits of text the system can display. Once again, you have complete freedom in how you want to organize this. I'm going to create one main object named after the system. This is to ensure that there won't be any clash with existing core Foundry text. And I'm going to add another level for attacks and then add all the strings for the various names. You can nest as little or as much as you want. DND5e keeps everything flat, but it means repeating the system name at the beginning of each entry. While I'm here, I'm also going to create entries for the other pieces of localizable text that we'll add to the weapon sheet. Lastly, we need to add this language pack to our system, and we do this in the system.json. A language pack is defined by three fields: lang, the two-letter language code, name, a human-readable name, and path, the path to the corresponding JSON file. Now we can go back to our config file and replace those hard-coded strings with the corresponding paths in the language pack. Next, we need to make the config object available. This happens in our main system file. We're going to import the config object from the config file, and in the init function, we're going to add a new entry to the app-wide config object that points to it. Now that it's available everywhere, we need to inject it into the context that's given to Handlebars. This is done by going to our custom ItemSheet class and overriding a function called getData. We don't want to reinvent the wheel, so we'll have to call the parent function and let it do its job. Then we can tack on our system config by adding a config entry and assigning our config.fs2 to it. Okay, we're on the home stretch. Back to our weapon sheet template. As you can see, the contents of items and actor sheets are usually HTML forms. The default item sheet template has a header section for the name of the item and its image. We're going to leave this as is, but we could rewrite it if we wanted to. I'm going to add a div element in which we'll be able to edit the properties that are specific to our type of object. In this instance, I'm going to go with a table, but at this point, the design of the form is entirely up to you. I mean, you are after all the Annie Leibovitz of how to lay out your sheets. So I'll have column headers for each of the properties the user needs to edit. I'm using Foundry's localized handlebars helper to fetch the correct string and render it. Next, we have to create the form fields. As you can see in the header, form fields need to have a name, and that name needs to be the path to the property the field is modifying. It also needs to have a value, which is going to be the value of that property. If you do these things, Foundry will automatically update the entity when you edit those form fields without you having to write any extra code. For dropdowns, such as our which stat to use this weapon with, there are special handlebar helpers to iterate through the possible options and select the one corresponding to the property's current value. For fields that are meant to be numbers, you need to add an extra attribute to specify that, or Foundry will log it as a string. There's also a helper for checkbox type input fields, as they work slightly differently from others. Below this, we'll add a section for the item description. For now, we'll just use a text area, but there's a nicer way of doing that, which we'll look at in a future video. And finally, this item sheet is complete. I can go back to Foundry, reload the world, open the item, and voila! I can now modify the various properties of my item, and if I close the sheet and reopen it, the changes should be conserved. It ain't pretty, but it's functional. This video has gone on for a while, so we'll call it a day now. Next time, we'll talk about making character sheets, which is mostly the same process, but there are some design considerations that we'll need to talk about. Until then, I hope this has been helpful, and thank you for watching. You know what to do.